AutoLine After Hours is brought to you by Bridgestone Tires, solutions for your journey.
Hey everybody, thanks for joining us on AutoLine After Hours. We've got an interesting show today. We're going to be talking about it. PHEVs a lot for the first half. We'll get into the news of the week in the second half. But let me introduce our guests. We've got Will Lawrie from Magna, Director of Powertrain. Do I have that right?
Program manager.
Program manager of Powertrain.
Yep.
Okay, I
you.
tried to give you a promotion. The show will help you get it anyway.
I appreciate it.
And we got Brett Smith, formerly of the Center of Automotive Research, but still a guy that knows a ton about this industry.
Still playing in the industry quite a bit. So.
Yeah, good.
He knows
good.
two or three things about powertrain too, doesn't he?
I've been around powertrain. It's good stuff.
Yeah.
Mm-hmm.
And then to make it official, hello, Gary.
John, how are you?
I'm rocking, man.
Yeah, good.
I'm busting to get this going.
So you guys have developed something called the Etelligent, that's with an E, Intelligent, all one word, Command powertrain system. What is it, and why do we care?
Yeah, that's a great question. The Etelligent Command is our version of what a potential PHEV vehicle could look like. We've been able to retrofit an existing vehicle, strip out the powertrain from it, and add in some of our own products today, right? So everything related to the driveline system we pretty much removed with while leaving the traditional 3-cylinder engine in place. We're able to implement a hybrid transmission, a 400-volt application, put in a higher power e-drive in the rear axle, and demonstrate a number of different technologies to the public, to OEMs, to internal customers as well. It allows us to show hardware, software, scalability capability, all of it. So it's quite a useful tool that we have.
Now, Will, the thing that caught my eye and why I really wanted you on the show is you're talking 70-mile range with this PHEV.
Mm-hmm.
Most PHEVs, you know better than I do,
Mm-hmm.
typically in the 20 to 40-mile range. So are you telling me you can take sort of an existing PHEV, plug-in hybrid electric vehicle, add your magic to it and significantly increase its range, or are you just throwing a bigger battery into the thing?
No, that's a good question. We do a number of different things to be able to kind of hit those types of targets. The cool part about this system is that we've taken a traditional multiple speed transmission, pair it with an electric motor, so you can get a highly efficient e-motor, and you don't have to worry about hitting both high speed and your lower torque or lower speed torque requirements, because you have the flexibility of the shiftable gears to be able to help you with that aspect. And then a blended approach between both the rear e-motor and the front e-motor allows you to kind of target the sweet spot of where to operate those e-machines to allow you to get a further efficiency benefit out of the system over what we may see in a traditional BEV vehicle.
So a new kind of transmission plus some software, you can get a whole lot more range?
Well, we take a lot of our existing products today. Magna supplies DCT transmissions globally already. We supply e-drive technology as well globally. A number of different clutch applications as well. And so if we kind of take some of those building block components and put them together into an application, we're providing something unique that you don't really see in the industry right now in an example technology that could be available.
So what I'm getting at is you're not adding a bigger battery to get the extra range?
No, we're not.
See, because that's so critically important. I know I'm preaching to the choir here.
Yeah.
You don't have to add a whole lot more battery costs to get significant more range.
And John, I kept waiting to get to the point there.
You're right.
Curious.
No, it's about smarter solutions, right? So we're leveraging what we have, what's known in the industry today, and try to apply it in a smarter way. So we're really trying to optimize a transmission system, an e-drive application, and a normal size battery. So
Okay, so you're talking about a dual clutch transmission, which for a while seemed to have a growing popularity, and it seems to me that that popularity has waned somewhat. Now, if we were looking at a conventional step gear automatic transmission, this wouldn't work with that?
In the way that we've configured it, no. The big benefit of this transmission is that you get those quick, seamless, very fast transmission shifts that we've come to know and love out of the DCTs. And then the blending of transferring torque between both the engine and the electric motor through those clutches is really what allows it or enables it to do it in the fashion that we are with this specific application. I haven't looked into, what it would look like if you tried to add your traditional step transmission, torque converter, and other accessories in there. But we see this to be the most efficient way to do it in this type of application.
One of the complaints, certainly it's been one of my complaints with DCT transmissions, especially with small displacement engines, is the launch, off the line launch. You don't have the torque converter. You got to mash your foot more into it. So you're using the e-motors to make up for the torque converter. Is that right?
Yeah, exactly that. So specifically for that maneuver as well, the huge benefit is having that e-machine with instantaneous torque, right? Available as soon as the driver pushes their foot to the pedal. And then we can either choose to blend in the engine almost instantaneously after that, knowing that the engines spin up a little bit slower than e-machines, right? Or we can choose to blend it in a little bit later if we want to target full EV driving range first, before we want to really rely on the ICE engine in that scenario.
So, Will, you have the front engine, front wheel drive motor engine. You also have an independent rear motor, right?
Yeah, that's correct.
Have you run the models without the rear motor? And can you do that setup and still get an efficient, effective vehicle?
Yeah. So the way that this vehicle is set up is we use it to do exactly that, right? We run studies of, a rear wheel drive based vehicle, a front wheel drive drive-based vehicle, all-wheel drive. And then our vehicle supervisory controls, which controls the entire torque management to the system, allows us to target what's the most efficient operating range if we were just in front-wheel drive or if you want to blend the two different e-machines. And that's a large portion of why we build these, technology demonstrator vehicles, is to be able to do those kinds of studies, work with the OEMs to show them, what's possible in different configurations, learn more, adapt the technology, and then eventually upgrade it and keep going. So
there was a time 2, 3, 4 years ago where everything was going to be battery electric.
Mm-hmm.
And your customers came to you and said, battery electric. Has that changed in the last 3 or 4 years where you're seeing more push now for some of these old-fashioned hybrids?
I think
this is a new fashion hybrid.
I
want to make that clear.
Newfangled thing.
Yeah, I think it's clear what we see in the industry is the flexibility for customers to select the technology that best suits them and their lifestyle, right? I think OEMs see it. We as, suppliers see it as well. I think it's important to make sure that we have the diversified approach to different technologies and how they can kind of play out for what the OEM's looking for, right? And the end customer. So you have to be flexible. You have to be ready to go on a moment's notice for a certain style of technology, if it's BEV, if it's traditional, or a blended approach, right? I myself am fond of the blended approach. I think there's a lot of opportunity there to use technologies that already exist today, not having to reinvent the wheel, and kind of, scale from there as we learn more and more about, some of the developing market.
The other thing is, it seems to me what you're describing here is almost just bolt-on without major tooling changes.
I make it sound easy, but there's a lot of complex engineering that goes into.
Sure, there is. But I mean, for an automaker, if they were to buy a system for you, they could easily retrofit it to an existing vehicle, or no?
We do offer bespoke solutions, but we also offer, from our product portfolio, traditional applications or more. Let's call it unified applications that we can do that type of project. I think it's important for us to make sure that we have the core building blocks, the core foundation of those types of systems, to make sure that we can provide a relatively easily integrated solution to the OEM. That's really what we want to focus on.
So this system's a PHEV system. Why did you guys decide to do that rather than just a conventional hybrid?
Yeah, that's a good question. I think mostly, the vehicle came as a PHEV off the lot as is, right? We know that they offered a hybrid electric version of this vehicle, so it was easier to integrate that way. But we did see a strategic opportunity where, knowing that the industry was going towards a BEV application very heavily early on, this was kind of a unique approach to be able to leverage some of the infrastructure there, to be able to leverage some of the maybe the modularity of being able to offer a platform that could be a BEV or could be a PHEV with minimal changeover, right? So you could, if you went from a traditional HEV to a full battery electric vehicle, right? There's some steps in between to get there at the vehicle architecture, right? So you're adding your charger, you're adding the plug, you're adding onboard diagnostics, so stuff like that. And being able to offer a solution that could easily go from an ICE architecture to a BEV architecture is also something that you could target with this type of application that went into the consideration when designing the vehicle.
I thought it was interesting when you were describing how you guys built this thing up. You said we kept the traditional 3-cylinder engine. So, I mean, so from a powertrain point of view, I mean, are you seeing that as becoming more common in terms of hybrid vehicles using smaller combustion engines?
I think it's probably case by case at this point. I think we see a lot of different directions from a lot of different OEMs. The important part is being flexible to that. So if an OEM does want to go to a smaller, downsized, more optimized engine, being able to interface with that, knowing what it would look like or take to be able to design a system that bolts up or adapts to that. But I think at the same time, if you wanted to go to a higher output system, we see a lot of performance spec vehicles out there, right, that we know we would have to interface as well. I can't say that there's a clear emerging trend, but I think we do see a lot of paths that OEMs are willing to explore at this point.
We may talk about this a lot today, but there's been this remarkable shift in technology in the last 3 or 4 or 5 years out of China, where 10, 15, 20 years ago, people talked about EREVs, and they immediately said, no, we don't do that. And in the last 2 or 3 years, we start to see a whole lot of EREVs, extended range electric vehicles, on the market in China. Is that going to happen here? Is that a trend? What when you go to make a vehicle, what now is different that says EREVs are viable versus the traditional parallel, not traditional, the newfangled parallel? I'm sorry, Tom.
Yeah.
But that thought process, because again, having watched the powertrain industry for 25, 30 years, there was a long period of time where people just ignored the EREV. And in the last 5 years, it's become something really viable, really intriguing.
Yeah. I guess when I look at the EREVs, what I see is the ability to get the benefits of maybe a BEV application, but and also pretty specific, I would say, to the North America region is that extended range that we've come to know and love from gas engine vehicles. I think there's been a lot of publicity around what's the right range for a BEV vehicle, and it seems to me that EREV technology is kind of bridging the gap between enabling the extended range and then the simplicity, yet also the maybe that instantaneous torque, depending on driver feel, less maintenance of the electrified vehicle space as well. So I can't say if it'll end up that way in maybe the North America, U.S. market region, but I think it's important to watch the Asia Pacific region and learn from what they're doing as well.
Well, just today on Autoline Daily, our newscast, we had reports of a Buick in China, EREV.
Okay.
502 horsepower, I think it was. Ford with the Bronco Sport coming out with an EREV, 1.5 liter displacement engine. I don't know if it's 3-cylinder or not, could be. But I think the interest in EREVs is that it might be a cheaper solution. I'd love to get your input on this, from the sense that you don't need a transmission, really. And you don't need a drive shaft if it's a rear drive vehicle. And because the extended range engine operates in a very small rev range, it doesn't have the same duty cycle, you can get fantastic thermodynamic efficiency out of it, as several Chinese companies have done. At the same time, they're taking cost out of that engine. So it just seems to me like EREV's time has come.
Yeah, it definitely could. I think it's also maybe vehicle specific, right? What you're targeting to use that vehicle for. What's the end goal of that application or that platform that they're looking for? But for sure, I could see in a scenario where that would be the most effective and maybe cost-effective solution as well.
Well, Ram was supposed to come out with a EREV pickup this year. I think it's been pushed back into next year. But that seems the perfect application to me. If you're hauling heavy loads, towing heavy loads, a battery electric, it just dies way too soon, or you got to put a gigantic battery in the thing. And even that doesn't provide enough range. An EREV does. So EREVs just seem like to be in the sweet spot for the U.S. market.
Yeah, it's an exciting technology to watch. because it'll be really cool to see how different OEMs kind of integrate that style of approach to their platforms that they have, or maybe even new platforms.
So how do you, and I'd love to,
Mhm.
PHEV versus EREV, what are your thoughts?
Yeah, I think when we look at PHEVs, they tend to seem a little bit more closer to what the average American is used to today. So for the users that are probably a little bit more comfortable with a traditional vehicle, it's probably something easier to get into when they talk about bridging over to the hybridization or the electrified area. And then if you have maybe early adopters or people who are, very quick to jump onto new technologies, I think that EREV application specifically, as you mentioned, is going to be a very popular one for those types of consumers. So I myself, I'd like to see the walk from the traditional products through the hybridized, the PHEV applications up into the BEV technology. We're kind of doing it all at once right now, right? Just from the market today. So I think time will show what's the clear direction for regional specific interest. But right now, at least in the US, we're seeing a lot of all types of technology. It's exciting. It's an exciting time.
So in your system, the Etelligent Command powertrain system, it has Magna's dedicated hybrid drive plus. What is that?
So that's the dedicated hybrid drive is what we refer to as DHD for the acronym, right? And it's a portfolio of transmissions that we have kind of taken from the DCT transmissions that we've learned in the past, some of our other traditional transmission business, and kind of electrified it to the 400 volt application space. And it's really a family of scalable solutions for electrified transmissions, and they're targeted on that electrified driving first, using the engine second, right? So whether the range is almost 70 miles there, or if you want to use it as a blended hybrid electric vehicle approach without your typical PHEV architecture, it's flexible and it's scalable to do that. But that dedicated hybrid drive is really a portfolio that encompasses a number of different applications for it.
So if you guys are getting 70 miles pure electric on this, what are you getting in terms of overall miles range from the hybrid system?
I guess as it sits today, it's as it sits today.
Answer, Brett.
I was curious to see what it is.
He has to answer the question.
So I guess I don't have a good answer for you in terms of a number. It's a prototype vehicle, right? That's been retrofitted with this application. What we're really focused on with that vehicle is to show that it's capable to increase that electrified driving range first, and then it becomes up to the customer to determine what size gas tank do they want to pair with it, how often do they want to use the engine with a blended strategy of the e-machine, or do they want to primarily focus on EV range first. So for us, our core component of what ends up in the vehicle is that first, let's call it 70-mile range of that technology as it sits today. So that's what we focus on within our division of powertrain, and how we can provide and enable the customer to do more. What the end result ends up being is really up to the OEM themselves.
Well, over the years, Magna has had this history of doing these demonstrators, as a lot of companies have. And they learned stuff from it. I remember, I think the Ford Focus 2012 was a Magna-based vehicle a long time ago. Then they had
it was a Fusion.
Was it
Ford Fusion?
Okay. All right. We'll go back and check that one. But so you've had this experience over time, and each time you learned something. What was your aha from this project? The thing that you will said, oh, that's something good we did, or something interesting we didn't know.
That's a good question. I wouldn't say interested didn't know was the aha moment, but maybe the wow, this is achievable is really the ability to drive. So with this transmission that we have in the front specific portion or front axle of the vehicle, is the ability to drive the engine and the e-machine through two different parallel transmission shafts at the same time. So that's kind of the aha moment for everybody who drives it, once they realize what's actually happening from the technology itself. So it's cool to think about from an engineering standpoint, because you're technically driving two different inputs to the wheels at the same time, but you also have the ability and the flexibility to shift between those two on the fly as needed. So if you're performing maybe a transmission shift with the engine to get the engine back into an ideal operating RPM, you can pump up your e-machine or your e-motor torque to fill in that missing torque coming out of the engine, and the driver never even knows it. It feels like you're, accelerating at a constant pace the entire time.
Sounds like this was a massive calibration project.
Yeah, there's a lot of work that went into it. It's a global engineering effort.
Can you do it simulation? Does that get you down the road, or does it have to be at a track or a proving ground?
No, we definitely do a lot of simulation work. I think it's important to leverage, especially with the way that technology is changing today and how fast it's changing. You have to be flexible to analyze these systems, make design changes on the fly. And you can't do that with hardware parts all the time, right? So we do a lot of simulation, especially on types of projects like these, to understand what's the impact of the transmission shift, how much, how big of an e-motor can you put in the system, what's required from a final drive standpoint, all of those types of things that go to simulation first before they even go to mechanical parts.
The 70 miles. Was that like a magic number, or is that where you ended up? Here's what we can achieve. And the reason I ask this is a lot of people in our audience are big believers in PHEVs, but they've been writing to me saying, I want 100 miles range. I think they'd be very satisfied with 70, but they're asking for 100. And I just wondered, is there any consumer research? Is there a magic number, or you guys just said, hey, we can get 70 and that's the number we're publishing?
No, I'd say it's a blend between, I guess, targets and what's capable of a vehicle that size. Sure, if we went to a bigger size vehicle, we could do a bigger battery and we end up with 120 miles, right? It depends on a flexibility and a balance of the system. So we had a target in mind, and 70 is very close to what our target was. It also drives, what size e-machine that you want to put in the vehicle. So you're really turning, 10 different knobs at once to get to your final result. And you may not end up on that exact line you're looking for, but 70 was for sure in line with the target of what we're looking for.
70 is impressive because that's one of my complaints about, we get to test drive a lot of PHEVs. And the nice thing about them is they're small batteries. So I come in here in the morning, I plug it in, and then by lunchtime, the thing's fully charged. But typically they get a lot less than 40 miles range.
Yeah. It's interesting to see the number of different technologies out there and how people are kind of approaching that same topic, right? I think the range of a electrified vehicle, whether it's a PHEV or a BEV, is a big topic right now, right? And so we see a number of different companies approaching it in different ways. We have our own approach internally, right? We don't own the entire system of the vehicle, but we contribute, largely to that being a driveline supplier. So
maybe you don't want to give away the manufacturer's vehicle that you gave, but what size vehicle more or less are we talking about? What size battery pack are you using to get this 70-mile range? And what's the chemistry of the battery too?
Okay, so I guess the battery pack, because it's a technology demonstrator, it's a prototype vehicle. I wouldn't say the battery is a productionized version of any battery out there today. So it's something that we've sourced from, partner companies to be able to leverage our technology and
but
showcase
it's 40 kilowatt hours or what?
We'll call it 22 kilowatt hour usable.
Really?
Is the size of the battery.
So it's relatively small battery.
When we talk about PHEV batteries too, we know we don't use the full size of the battery as well, right? So when we say usable, that's really the range that we're using for our application in this specific vehicle. But the transmission
NMC battery,
I'd have to go back and check. I don't remember off the top of my head what our final chemistry came down to be. But when we talk about size of vehicle, the configuration that we have between the rear axle e-drive and the transmission, the hybrid transmission in it, we're looking at the CD segment class for this specific, but we know it's scalable and we know we can go to larger.
Crossover?
Yeah, about that size, right? And that's the typical size of the Range Rover Evoque that we decided to park it in for this demonstrator.
So you did say what?
It's right in line, yeah.
I kept saying there's a picture of it on your website.
Yeah.
Something. Yeah. Did I not see that? Yeah.
It's up on the screen right now.
There we go. Sean's got a picture of it up there. Yeah, because what I love about this approach too is it seems to me that you could probably use an LFP battery, maybe not as energy dense, but maybe give up a little bit of range, but absolutely take some cost out.
I thought we wanted more range, John.
Yeah.
I know, but I'm just saying, everybody's complaining about the cost of new vehicles these days. So anything that you can do to take cost out and still come very close to.
You probably don't put it in a Range Rover and that'll bring the cost down.
We're focused mostly on the how do we get the power to the wheel standpoint, right? So the core exercise with this demonstrator vehicle wasn't necessarily the battery or the chemistry. It was about leveraging the technology that we had to enable, I guess, the customer, the end customer and our customers to do more with what they currently have available to them, right? In a very fast time. So it's one hand, we talk about how efficient it is, but on the same side, this vehicle is quite capable to do some very impressive things, whether it be on the track, in a snowfield, at a proving grounds with an OEM.
Off-road?
Yeah, exactly. We made it as flexible as possible to show the different use cases, because not everybody uses their vehicles the same way. Not everybody uses a specific technology the same way. We know that, right? And we have to protect for that. So being able to show how we can design something that fits all of those different areas is important as well.
So to what extent is the magic of this system predicated on integrating the motor in the transmission?
It's very important. I'd say with this specific application from our portfolio, it is the key feature of that transmission, because it's paired with the DCT, because it's capable of driving through all 5 speeds, because you're capable of doing it in a parallel or a series hybrid operating mode. How it was architected and integrated into the transmission is everything for this application.
So is this a pancake motor between the engine and trans, or it's built right into the trans itself?
Yeah, I like to call it a P2.5 because it operates similar to a P2, but it's kind of nested next to it in a way that we can drive through 2 different parallel shafts at the same time. So almost like split input, but functioning slightly different as well. So it's a unique application, right? I haven't seen
I've never
anything
heard
out
of
there
anything
today
like
that
this.
operates in a similar fashion. And that's why I love showing this vehicle to everybody. I love explaining the technology in the vehicle. We have a nice center display that shows power flow as we're driving. And it clearly shows the unique behavior of the system relative to what we've seen today.
How does it drive? Because one of my complaints with strong hybrids is, especially with CVTs, is this disconnect between what the accelerator input is, i.e. my right foot, and how the engine is revving up. And I still don't like them. I still don't like them. Whereas, I prefer much more linear kind of input and output, i.e. when I put my right foot down, I want it to react exactly with what I'm feeding into the pedal.
Yeah. With the precise control you get out of e-machines, right? We have software that controls, in our vehicle, at least, EV operating first. So you can set it up to be linear to your pedal. You can set it up to be, different types of driver comforts. But the way we set it up is such that you get that EV operating range first. So your electric motor is very controllable, and you can kind of, give an aggressive or a subtle feel to it. And then you don't even know that the engine really is doing anything if you really get into the throttle, except for hearing it if it maybe turns on. Because you have such precise control over the e-machine, you can kind of feather or blend in your torque strategy. It's a huge benefit to having vehicle supervisory controls, right? Being able to control rear, front, blend the two, left to right, side to side with torque vectoring capability. There's a number of different things you can do there. But I personally love the way that we set up our vehicles because, we show them off all the time to journalists, to automotive news outlets. We do it with the customers. We do ride and drive events all the time. So it's important that these vehicles drive as close to production as possible. So we take pride in that.
So let's say, for the sake of argument, that John is in this vehicle. He gets on 696. It's got a full charge of the battery. So you got the 70-mile range there. And because he's John, he puts his input device, i.e. his right foot, to the floor. Okay. Is this going to bring in the engine and the electric motors, or is this going to be powered by the electric motors because it's got the full state of battery charge?
You can do either. We've set it up so it's flexibility to both. We've shown it where it doesn't even turn the engine on at all until you get to a depleted battery state of charge, and then you have to turn the engine on, and you can drive with the engine and charge through your e-machine. It's set up also such that it could do, let's say, call it above 50% pedal. Maybe you kick on the engine there. And you only operate in the EV range for low pedal inputs. Maybe you're around town, you're targeted more of a city driving environment, or you can set it up so the engine turns on as soon as you're basically cruising along from a stop sign. So having the flexibility to do both is important. But I prefer when it starts in EV operating mode first, and then it goes into engine strategy later. So.
Yeah, I agree with you, by the way. Look, we're going to have to wrap this segment up, but I also want you to know that I volunteer to test drive this anytime that you guys have got that thing open, because I'd love to experience it.
Yeah, we'll have to get you out and give you the whole run through. It's there's a lot of technology in it. There's a lot of different things to show, but it's by far my favorite demonstrator vehicle that we have to drive. So let's get you out and let's get you in it.
Real good. With that, we're going to have to wrap this up. Will, thanks so much for coming on Autoline After Hours. It's been great having you here.
Thanks for having me here, guys. I appreciate it.
Making a life full of memories, one road trip at a time. That's what really matters. Bridgestone Weather Peak tires with a 70,000-mile limited warranty.
Seriously, though, we'll talk about getting you guys in the car.
Good deal. Good deal. Welcome back. Now we're here to talk about the news of the week, and maybe not just the week, but other big issues going on in the industry. And I know, Gary, you put together a pretty good list of things.
I got a quiz for you first, John.
Dr. Data, or is that?
Yeah, Dr. Data.
He's gone.
Yeah.
So on July 17th, 1985, Ford introduced a vehicle that basically went out of production around the same time as, I forgot about the existence of this vehicle, the Ford Aspire.
Okay, yeah.
Ford Probe.
Yeah.
And the more memorable Thunderbird and Cougar. So what vehicle went into production today at Ford on July 17th, 1985?
40 years ago. Right?
So the Aspire, if I remember right, was a Kia.
But they went out of production around the same time.
Oh, okay.
So I'm just trying to give you some context.
So it came and left in a decade and a half-ish.
Yeah.
I was going to say the Taurus, but the Taurus is a little later.
No. Taurus came out
Really?
in
84?
In that time frame.
Not the Taurus.
It's not the
I
Taurus.
didn't think it was going to be the Taurus because they had kind of multiple lives. No.
Yeah, I'm blanking out.
There's a guess. EXP.
Okay, one of the people in the chat room said the Ford EXP. That was out sooner before that. The EXP was based off the Escort. It was a two-door, quote-unquote, sports car. Ford called it a sports car. I don't think anybody else did.
It was a Mercury Capri, but that was later.
Oh, no, I don't. Was the Capri later than that?
I think the Capri was 89.
This was a rear drive vehicle. We're getting.
Okay, so Capri.
But it's not the Capri.
No,
the Capri.
Nope, no idea.
Okay.
Move the show along.
Ford Aerostar.
Oh, the Aerostar minivan.
Of course.
Yeah. Close?
Of course.
Oh, they said close.
It's
like Jesus.
Why shouldn't, John, we should know that.
Well, we do know it. It's just in the recesses of our mind. That's all. And
But the thing that surprised me when I was looking at this, that it was succeeded by the Ford Windstar.
Mm-hmm.
Succeeded, yes.
And then it was followed by the Ford Freestar.
Which was the Windstar. They just put free on it because free was a cool name at that time.
You think?
Yeah. Yeah. Free was cool. Free ride.
Free was cool.
Free was cool.
Now,
then came the Ford Flex, which was their kind of next step of a.
No, but these were all minivans.
I know,
though,
but that
right?
was the kind of that.
But remember, there was one of those, and I can't remember which was built. Ford actually built minivans for Nissan.
Yeah, the Quest, the Nissan Quest, and the Mercury something. It was a Nissan and Mercury models.
Yeah.
They were nice old vehicles.
But that was a different than these.
Yeah.
But
okay.
All right.
Let's
move on.
Let's get to the real fun
Let's
stuff.
move on.
Yeah.
Okay. So I thought this was more surprising than the Ford minivans. That so Uber is going to be investing $300 million in Lucid, and also going to be investing in a company, Nuro, that makes self-driving vehicle level 4 technology available. And they're planning on deploying more than 20,000 Lucid Neuro robo-taxis, and the first vehicle is supposed to come out next year. Isn't this crazy money? $300 million?
Well, Lucid loves it. I can tell you
Well,
that. They need the money.
But there's a common investor in both of those companies. The Saudis are invested, I believe, in both Uber and I think it's Uber and Lucid.
Lucid for sure. I didn't know that they have invested in Uber.
I think it is. Two of the three companies had Saudi investment, I'm pretty sure, which might have been a way to pass some money to keep things going.
Well, Uber's profitable in and of itself right now. It's doing pretty well. I don't know is that they need any Saudi
to
money.
Lucid.
But Lucid needs money.
Yeah.
They need even more than 300 million.
Yeah, so you go from here to Uber to Lucid, and makes it look more positive. Theory.
Maybe, but I think this is interesting. I was not aware that Uber had invested in Lucid. And is Lucid going to build a purpose-built robo-taxi for them?
It sounds as though they're going to be building this into the Lucid Gravity, their SUV. And so they're going to be taking the Neuro Level 4 system and integrating it on the line in the Casa Grande, Arizona plant to start rolling out these things, next year.
For three people that have been in the auto industry a long time, how weird is it to say that Casa Grande, Arizona assembly plant? It just doesn't come.
It doesn't click.
Does it? But it's also interesting because they have a similar arrangement with Volkswagen. So they've got two different fleets developing. Uber does. And just again, you saw the decline, and now you're seeing the rise back up very quickly of the automated vehicle bubble.
Well, Uber just cut a deal with Waymo to have Waymo vehicles in the Uber fleet in Atlanta. Yeah. And I think they're talking about some other cities too.
So is this another bubble, or is this that actual where we're going to start to see this happen?
I keep saying 2025 is the year of the autonomous vehicle.
Yeah, but so was 2017 and 2018.
Yeah, right. And we all thought that at the time, or certainly I did, because that's what all the experts thought. But now it's happening. I mean, look at how many cities Waymo is expanding into and overseas. And look at Baidu and Pony and in China. And, Zoox is coming on, Aurora is coming on. It's starting to happen.
Uber also has a deal in the U.S. for robotaxis using ID buses with Volkswagen. And Uber just recently this week signed a deal with Baidu for China and for international markets.
Yeah, Sean's filling us in with more details here of where Uber is investing.
Again, it's fascinating. It's really interesting. And it may be that inflection point.
Well, I mean, I think what's interesting is that if you remember, Uber used to have its own autonomous, advanced technology division that they said, well, maybe not, and that went away. So it seems now what they're doing is they're buying systems.
Right.
So is this the approach that companies are going to be taking in order to get autonomy into fleets? Is buying it from someone else?
So, absolutely. Look. GM, Ford, Volkswagen all threw in the towel and felt that developing this technology was beyond their ability to spend. And so why not rely on companies whose sole existence of purpose is to make AV technology? And I think it's really smart for Uber it obviously made the same decision years ago that, man, it's expensive to do this. And what's our forte? Our forte is providing rides to customers. Our forte is not in developing AV technology.
What role does the change in administration here have to play in this enthusiasm? The previous administration wanted to put guardrails on this technology.
Right.
The current administration is much less interested in guardrails.
They want to accelerate
it.
Absolutely.
So does that... Again, I go back to, I don't know. This is a fascinating technology. It could be life-changing. But is it another hype cycle because they see the government, again, electric vehicles, government pushes, the hype cycle happens. Is there a real business case, long-term model for the midterm model for this? Or is it just another stepping stone to get closer?
Look, I don't think Uber would be spending this kind of money unless it thought there's a payoff in it. Now, there's some study that just came out in the last week that said it's going to take 7 to 8 years for any of these robo-taxi fleets to start making money. I personally don't believe that. I don't think that even Uber is taking that long a term of view of.
You think it'll be shorter?
I think it'll be shorter than that. That's just my opinion. Yeah. We all have opinions, right?
I don't know.
But I remember when there were studies that came out and said robo-taxis will never make money. They're always going to be more expensive. But clearly there's a lot of smart people out there that don't believe that that's the case. And they happen to be in China and the United States.
There are a lot of smart people at General Motors that sunk a lot of money into Cruise. So let's.
Yeah.
It's again, developing new technology is really hard, and you don't know what the outcome is going to be.
Yeah.
Right.
That's why you win big, you win real big.
Yeah. Okay, next topic.
All right. So speaking of General Motors and smart people, so a couple of things announced by General Motors this week in the battery space. One I think is more interesting than the other. The first one being that the Spring Hill battery plant is going to start building LFP batteries. That's the plant that the Ultium plant, which is General Motors and its partner LG Energy Solution. We had Bob Lee on the show, who's the president of LG Energy Solution for North America. What I thought was interesting is 2 or 3 weeks ago, LG Energy Solution opened up a plant in Holland, Michigan to make LFP batteries for what? Oh, that's right, energy storage.
Not for cars.
Not for cars. And General Motors announced also this week that it is with its joint venture with Redwood Materials, which started Redwood Energy. They're going to start making batteries for data center and local energy storage use, which is what one of the main things that's going to be happening in the Holland, Michigan plant. I'm seeing this, that General Motors is saying, you know what, we can build batteries, but maybe these batteries are not going to be going in as many vehicles as we thought. And the energy storage market is just exploding. I mean, with AI and data centers
and Bitcoin farms.
Yeah. I mean, it's just like, man, there's a lot of energy that we need. And oh, by the way, the grid ain't so great.
There are two GM stories this week or last week or so. One is the trucks, maybe we'll get back to that, but two is the batteries. And it goes back to something that when you introduce a new technology that is changing so rapidly, you're pretty much guaranteed that you're going to change your manufacturing system before you get much of a payback on that first introduction. And the iterations of new manufacturing, of new chemistries, is really expensive. And you know that GM didn't get payback on that first set of tooling and machinery. The question is, will it get payback on the LFP before they go to LMR or some new technology? And how long can you do that to get to the point that people actually have a battery that they'll accept in their car in high mass quantities, mass volume? Or do you find other markets, which I think this other markets part is really fascinating.
Yeah.
So what do you think, John?
No, look, I think you nailed it, Gary. The energy storage business is booming. You've sunk all this cost into making batteries because you thought there was going to be a lot more EV sales. Now the EV sales are nowhere near what you thought they were going to be. To Brett's point, find a secondary market. And so I think this is a great step forward for EV technology.
And I think they're going to make money, Brett. I don't think this is any question. I think that they're going to.
This is that market is a viable market. Not pivoting from EVs to stationary is a viable market, is what you.
Yeah, So I mean, you're thinking, well, new technology takes time to make money, blah 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 blah
right,
blah. I'm like, no, they're gonna this one they're gonna make money on.
LFP will be used for that for a pretty reasonable period of time.
Right.
Whether it's used in automobiles for any length of time is still certainly in question. But to get that secondary market, or that first market, and use the auto as a secondary market, the Redwood story, I think, is also interesting, in that they're supplying the refurbished reuse batteries. I will admit, I was one that did not believe that you could, long-term strategy to pull an old battery out of a car and put it into a battery farm somewhere. I thought the complexities of that would just make it more easy to go straight to the manufacturer and get a new LFP battery and put it in there. It'll be interesting to see how Redwood, who has some really smart people there, and GM, Redwood works together with this and takes those technologies and creates those battery farms with used electric vehicle batteries. Because, again, the cynical me said that doesn't seem like a good strategy.
No, I'll verify what you thought, because, and this has got to go 8 years ago, I talked to several different utility companies, DTE in Detroit, Consumers in Michigan, Pacific Gas and Electric out in California. And they said, we're very interested in these batteries, but not used ones. We want new ones. Now, that was then. We've learned so much more about how to make batteries and make them last, and they are lasting, by the way, that maybe the utilities will be persuaded. Yeah, if it's that much cheaper to buy a used one and it comes with a warranty, I suspect that GM and Redwood will supply some sort of warranty on it. Maybe the utilities will go for it.
John, back to Will's point about the controls, or your points about the controls, and the ability to better control the batteries and better create, this harmony amongst these very diverse batteries. Maybe it works.
Well,
pretty cool.
Think about the application, though. I mean, so if you're just sticking it in a box, and the box is sitting in a room, and the room is got air conditioning and heating and whatever HVAC that they need, it isn't moving around. It can be reliably recharged when they need to. The duty cycle is known. There's and so
but the state of those batteries and the differences between all of them, apparently they're really comfortable with it,
right?
Which is cool.
So I think that
really
that
cool
would
idea.
completely work out for them.
Okay, next topic.
All right. So again, General Motors announces this week that the Lake Orion plant will be, Brett, trucks. And the Escalade. So we're going to move the Escalade out of Arlington, Texas, and move it to Orion. Now, what's interesting about this is, staying with this theme more or less, is that's where the bolts used to come from. So it used to be electric vehicles. Now they're going to be putting in pickup trucks and Escalade.
Well, little history of Orion. It was making bolts, like you said. And then GM said, we're going to this Ultium platform. The Bolt is not on that platform. Ergo, we got to get it out of our lineup. And the customers went ape. It was like, well, we love our little Bolts. We love it. And it was inexpensive, with the rebate and everything. You could get it. You could get them pretty cheap. I mean, $22,000 brand new, even less than that. So anyway, GM acts as that. And then it says, we're going to build EVs in that plant, because at the time when they made that decision, everybody was only talking about EVs. And then you come to today's reality, and it's like EVs have not materialized like everybody was counting on, everybody in the industry was counting on. And now you've got the Trump administration saying, hey, we're throwing tariffs on everything, especially on Mexico and Canada. GM makes a lot of trucks in Mexico and Canada. And their Arlington plant, which makes all their full-size SUVs, Escalade, Yukon, Tahoe, Suburban, is busting at the seams. They've been running that plant at max overtime for years now. When you run a plant like that at max overtime, your people love getting the overtime money, but man, you give up your life. You get worn out. It starts to beat you up. It beats up the equipment. So GM is saying, okay, let's pull the Escalade out of Arlington. We'll put it in Orion. We need more pickup production now, because guess what? We're not going to be importing as many trucks from Canada and Mexico. We've got, Fort Wayne, we've got Flint, we've got our other trucks and plants in the U.S., but we can't put all that production, or we're into the same problem that we had at Arlington with max overtime. So bingo, let's put it in Orion.
So I'll take a different direction on this. Absolutely agree with everything you said. But the GM executive team has got to be brilliant, because when they went from Bolt to EV, they got an enormous investment from the federal government and got pats on the back from the president, and were just wonderful people. They did what's right for America, and now they're doing the same thing by flipping it to a truck. And the president is going to say, "See, I brought you new jobs."
Right. A different president.
A different president. Thank you. A different president. Important. But again, pivoting to fit the technology, fit your product to the market, is really expensive. It really is. And this is a kind of, well, they're doing this because of the tariffs, regardless of why they're doing it. And it's certainly good that they're bringing this back to the U.S. Although it's expensive. It's not cheap. They're going to have to. I have not been in that plant since they redid it for the big truck EVs. But I'm going to suspect they're going to have to do a little bit of work on that, aren't they? To put new equipment in there?
Absolutely.
That's expensive to do that and not produce any product out of that plant for one whole iteration and then go to another iteration. That's tough.
It costs money. But you'll recall 2 months ago or whatever it was, we had Warren Brown here. He told us then they're going to put the Silverado and the Sierra and the Escalade in Orion. I mean, 2 months ago on the show we had it. GM only announced it this week. But Warren's read of the whole thing was GM's looking at what's going on with EVs, not where it thought they would be. It's looking at the tariffs. It's going to impact Canada and Mexico. So what he said is, this is really GM looking at its U.S. manufacturing footprint and balancing it out.
And a local kind of thing. That plant has had a really challenging past. It's got lots of different products, and it's never really connected. The crew that works there has, been off work, been back on. Building trucks is a pretty good thing for them. Building internal combustion engine trucks is a really good thing for them. You can't expect anything to last more than 5 years, but that's a pretty good. So good for them.
So this leads to the thing that part of the budget bill that was passed and signed by the president is the fact that basically, if you're building and you don't meet CAFE targets, you're not getting a penalty. So does this mean we're going to see more things like Orion building pickup trucks and full-size Escalades and lots of things with internal combustion engines versus EVs?
I think that's a pretty logical outcome. It's what the market, for the most part, wants. I'd go push back a little bit, John. You said everybody thought that we'd be going to EVs. I think Toyota really didn't.
Correct.
And I think there are others that kind of said, "Oh no, this isn't." But yeah, I think it makes sense as a company to be flexible, so you're not tearing out the technology, the manufacturing process. You're able to build different products on the same line or very similar. BMW does a wonderful job down in South Carolina of being incredibly flexible. They've built their products, and they got scolded by a lot of folks 6-7 years ago for not building only EV architectures, for building flexible architectures. I think that comes back to the idea that we don't know where this market is going. Yes, China was going very EV, and they're still heading down that path, except for EREVs. But we don't know with the U.S. market what is going to happen over the next 3 to 5 to 10 years, and we've got to be flexible. And instead of making an announcement, building a plant or building a manufacturing system, and then saying, "Oops, we'll rip it out and building another one," the idea to be very flexible, and when you put in a facility, make it so it can build lots of different products, including ICE going forward, but converting to EREV or PHEVs or EREVs or BEVs.
So you're suggesting this is what they're doing. I mean, so if we have the BMW example, as you said, they designed their vehicles specifically to be able to be used in different ways.
Yes.
I don't think that's what they're doing at General Motors.
No, they're not.
So when you're talking about, this flexibility, but what's the flexibility? Where's their flexibility?
I think that the point being that, and I talked to several companies that did build the flexibility, and they said, we need to be able to build more than just EVs at this plant, because we honestly don't know this. And it was several of the companies, most of them south of the Michigan-Ohio border, were building that flexibility. Now with big heavy trucks, you make so much money on those and you're going to build a lot of those. It's not as important maybe, but this idea of understanding that there's nobody in this business that knows what the market's going to be in 5 years, 8 years, 10 years. And instead of jumping all in and putting all your eggs in one basket, the old cliche, those companies that have been pretty good at being flexible, Toyota, BMW, others, tend to have a pretty much more positive forward motion.
I would agree with that. But getting back to your point there, Gary, will the market absorb more pickups, ICE SUVs? I would argue that the market's pretty much saturated right now. So I don't see a big increase in ICE vehicles. What I do see for the automakers with the CAFE fines gone is their planning is going to be so much easier, because they literally had to look at, wow, we're selling so many trucks with V8s and with turbo 6s or with inline naturally aspirated 6s. And they have to track these things literally by the unit to say, wow, we're bumping up against our CAFE limit, or we're bumping up against our CO2 limit. So we have to limit production of these, and we have to increase production of those. And now if the fines are gone, you build to what the market wants. But does that mean we're going to see more ICE production? I don't think we're going to see much at all, because the market is
the market is what it is.
The market's not growing.
Okay, so, but does this mean that we will see more ICE and less EV?
I don't think so. Well, yeah, because number one, the Trump administration has gutted all EV incentives. That's absolutely going to have an impact on sales. Just that alone is going to lower EV versus ICE. But there's a natural market demand for EV. Mm-hmm. There's a lot of people sitting on the sidelines that are like, I want more range, or I want to see more public charging stations or whatever. But once those concerns are satisfied, they're gonna go out and buy an EV and see if they really like it or not.
Gary and John, can I ask? So there's the fines, but there's also the credits and the EPAs where Tesla bought or sold credits for a lot.
Apparently, credits are going away as well.
And that's what I just knew things were fluid. I hadn't heard for sure if that was it.
Right.
But yeah,
that's gone.
That changes a lot of business models for a lot of people.
Listen, if we don't have Tesla's Q2 numbers, we have the first quarter numbers. If you take out their regulatory credits, they would have lost money.
Tesla was doing pretty good with that, even without that credit. But that was before.
Prior to the downfall,
that was before
they were fully profitable without those credits. The credits were the icing on the cake. But now, with sales down, with revenue down, those credits are critical to Tesla. And like I said, they would have lost money in the first quarter without them.
And Lucid and Rivian might have similar challenges?
Similar, right. Now, the only
Not Lucid, they just got $300 million.
Well, that's where they got the $300 million to cover.
Yeah, right. Yeah, it's going to hurt them, but Tesla was the one that was making big money off the credits.
So speaking of Tesla, they just lost their head of North American sales service and delivery, vice president. So far this year, they've lost their head of North American European operations, vice president of engineering, who is in charge of Optimus, your favorite robot. Their director of HR, their VP of software engineering, and another guy who is a battery executive. So 6 big people gone from Tesla. Sales down, Elon talking who knows what. What's going on with that company?
Look, this sounds very similar to Stellantis in 2024, with all these executives jumping ship, and because they saw the writing on the wall. They didn't like the way the company was being run by the CEO, Carlos Tavares. They saw the writing on the wall that, man, things are going to get really bad. Why don't I bail now and see where else my career takes me? That's what I see going on at Tesla.
So they're kind of like a real car company now, at least.
Unfortunately, yeah.
Unfortunately.
I say unfortunately because, look, Tesla, and you guys know, I was a severe critic of them until, I got to drive the products. I got to, talk with Monroe and Associates and the guys at Carasoft and see what brilliant engineering was going on. And they were so innovative and and now they're kind of like a legacy automaker.
I always went by they're showing the world how hard it is to become an automaker, but how you can be creative and do things differently and become a different kind of automaker.
Right.
Now it's going to be real. It's going to be a, get your popcorn, sit back and watch, because it's going to be fascinating.
So, I mean, why do you think that is? Is it because of the leadership of the company? Is it because the other car makers are beginning to have product that competes with their product? Is it because of the Chinese competition? Or is it because the market is becoming less intrigued with EVs overall?
I think it's all of those. I think it's hard to underestimate Elon's impact on the growth of this company and his impact on the challenges of this company right now. It's just a pretty darn remarkable story. And I think that as you look at where they are, they're still building pretty good cars, very good cars.
Yeah. There's
still a market for EVs out there. Yes, they have competition, but they're still as good as anybody's vehicle. So I think at the end, it comes back to a good portion of it is for the growth was Elon, and I think for the downturn is Elon. Now, they would not have kept on that growth. Clearly, they couldn't keep that growth pathway up. But yeah, it's a leadership thing.
It's a leadership thing completely, Brett. I agree with you. Look, Tesla's biggest problem is that Elon's foray into politics drove a massive amount of the customer base away. Sales have almost collapsed in Europe. They're down significantly in this market. Why? Because who buys EVs? They tend to be liberal Democrats, right? And they hate Elon's politics. And so they refuse to buy his car. I've seen pictures, I've run into people who know of people who put Honda badges or Subaru badges on their Model 3s and Model Ys.
I hate Elon too.
Yeah, or I bought this car before Elon went crazy. And so, I mean, I've never seen an executive drive customers away from the product like Elon has.
So all of these challenging things you brought up today and Will's technology remind us of how cool it is to watch this industry. I'm not sure it's cool to be on the inside all the time, but the three of us have spent 100 years combined watching a really cool industry.
It's the best time ever.
Oh.
That'd be you two have like...
Well, yeah, he's
90,
pushing 70.
90 years.
Right. Anything else, Gary, or we wrap it up?
Oh, I think we should wrap it up. I did think it was interesting that, Kelley Blue Book came out with their numbers for electric vehicle sales. And, we're talking about the travails of Tesla, and looking in this market anyway, they've still, for the year, they've got 45% of the market, and there is not another single brand that has above 10%.
They're still a really good,
it's just
strong product.
You look at these other, and like we're all like, whoo, Chevy's doing so great, 7.8% of the market.
You've been to the teardowns. You've seen the brilliance that they do from model to model, from iteration to
Tesla. You're talking about
Tesla.
Yeah, absolutely.
People talk about them. Well, it's the same Model 3 that was on the road in 2018. No, it's not.
No,
they've done incredible stuff to get from where they were to where they are.
Right.
Yeah, it may look the same, and I've always thought it was a goofy as heck looking car, but it's sold well, and it's still a great car.
I totally agree. Look, I want to see them survive. I want to see them get back to get their mojo back, as it were. But that takes leadership.
I want to see them crash because it'd be a fun, get the popcorn kind of thing. Nothing against Tesla at all, or great, but man, that makes for great theater.
Well, it might make for great theater, but I think Tesla absolutely changed the automotive industry.
It did.
I would like to see them get back to, poking the industry to get going faster and be more innovative. So I want to see them succeed, but it takes leadership, and I don't see it coming right now.
You're a positive, I'm a negative.
Yeah. Okay,
Brett.
We'll wrap it up. Brett, thanks so much for being back on.
Always great.
Always good. Gary, always good to be with you too. And I want to thank all of you for having tuned in.
AutoLine After Hours is brought to you by Bridgestone Tires, solutions for your journey.